Hello everybody and welcome back. I'm Karen Jr. and this is a second episode of the Let's Play of Aurora 4X. There are a couple of things I've actually forgotten during the last Let's Play, so we'll start again here at this start screen. Down here there's a drop-down field concerning detection. It means what is used by the NPRs regarding detection. Normal in all systems means they use the same means as we do, namely active and passive sensors. But there are two other settings which affect gameplay, and since we are starting with a couple of NPRs already in-game, in addition to the precursors, invaders and the Star Swarm, I would like to lighten the calculation load for the game a little bit. The other two options are none without player systems. It means presence. It means if we are not there, there will be no detection. Sounds pretty awful. And the final one is automatic without player presence. This means the NPRs will actually not be using their active sensors or over the sensors in order to detect enemy ships, but will detect them automatically in the system they're currently in, as long as I'm not there. As soon as one of my ships gets there, they will switch back to standard detection mode, and this will make it a lot easier for the game to calculate what is there and to try to intercept ships, fire missiles, fire weapons, and so on. Okay, another thing I'm not sure I've covered in depth last time was this difficulty modifier up here, the 300%. But first we will save this automatic detection and jump into the game. We'll start with the system information display because I want to show you. I have to activate Space Master first. I want to show you what the 300% actually means. Okay, I'll start with the standard screen and go to system from there. We'll create another dummy empire. The name is unimportant. If you recall, we start with 500 million population, and population directly transfers to manufacturing, research, shipyards and other important features. The 300% difficulty actually means NPRs which are created during the game by the computer will start with 1500, and as you can see, this equals more research points, more industry, more shipyards. So this is what we'll be going up against. And there's an additional modifier due to the time elapsed since we started the game. Basically, the longer we have played, the more population, the more industry and the more tax the NPRs which are created at this point in time when we meet them, they will get. Okay, but we left at research the last time around. A couple of oversights by me here as well. One of the things I've noticed, I haven't picked any turret tracking speed. Since we'll rely on Gauss cannons and turrets for missile defense, it's fairly important to have at least some turret tracking gear here. Essentially, this means how much weight has to be allocated to the turrets in order to reach a certain tracking speed. Since it's just 1000 points, we'll take this. Another thing I've overlooked is jump drives. We do have basic jump drive technology, but without researching those three jump drive tags, at least at basic levels, will actually not be able to construct a jump engine. Therefore, we will need those tags as well. Jump drive efficiency essentially governs how large our jump engine has to be to move a certain mass of ship. The higher the level gets, the lighter our engines are getting, but we will need at least one. Jump squadron size means how many ships can jump together with our jump ship. 3 means essentially 3 ships can jump with them. The size modifier back here, I think, governs if the ships accompanying our jump ship are able to be larger than our actual jump ship, because normally the accompanying ship's size is limited by the size of the jump ship itself. So we take this as well. And finally, squadron jump radius determines how far away from the actual jump point our ships are entering the new system. This is fairly important in case the jump point is defended, because the defending fleet will usually sit right at the jump point, and since our ships will suffer from jump disruption, it will take them between 1 to 2 minutes before their sensors are back online, and ships with no sensors cannot fire. So essentially we're sitting ducks till our sensors are back. So it might be a good idea to not enter a system exactly at the jump point, but some distance away, so either the enemies will not be able to hit us or not be able to hit us as hard as would be the case if we emerge right at the jump point. Instant this as well. Okay, we've got a problem now. We just have 1,500 research points left, and we have not constructed any ship components, prototypes, whatever you want to call them. But I'll go along anyway, because I don't like to restart the game to make up for those oversights I made, or those mistakes I made earlier. In addition, I use certain kind of house rule here. If you take a look at the race details, you can see our current research rate due to the tags we've already selected, 280 in this case, and my personal house rule is I will not really research any components which will take up to my current research rate. So small components will be researched instantly during the game. For now, I'll have to cheat a little bit and add some more components, even those which are larger than the research rate. Okay, but back to our components. There are a fair number of components to research. We will need about half of them. The others we either don't have the tech for, we will not need them at this stage of the game, or we will not need them at all. The most important tech at the moment, in my opinion, are engines for us, because each of our ships has to have an engine, with the possible exception of orbital habitats, which we'll get into a bit later. Okay, engine technology. What do we have here? We have a power modifier, which basically determines how much engine power points are generated by a design. Currently we have modifiers from 0.5 up to 1.5. Not a very large range of options, but they will get better as we research better efficiency tags later in the game. Fuel consumption governs how much fuel we are using per liter of engine power. Thermal reduction is nice to have if we want to create engines which don't show up as soon on enemy passive sensors, but not important for now. Engine size, another very important point here. It goes from 1 up to 50, and this stays constant throughout the game. And fuel consumption is lowered the larger an engine is getting. So if we would build a commercial engine, for example, there are two prerequisites for building a commercial engine. The first is the engine has to be larger than 25 size and has to have a power modifier of 0.5 or less. So for example, if we would construct a 50 size point engine with a 0.5 power modifier, it would yield 300 engine power points at ion drive technology. Those points would go up with higher technology levels. For example, our low-techs thermal engines just 125, nuclear 200, ion 300. As you can see down here, those 300 points are produced by a size 50 engine, and the research project would cost us 750 points. And this engine is fairly power efficient. It would use 24 liters per hour in order to get this kind of power. If we would construct a military engine, it would look a tad different. 25, it would still be a commercial engine at this point because the 25 prerequisite is still met, but we will up the engine power to 1.0. This would produce the same 300 engine power, but our fuel consumption jumps up to 200 liters. But, and this is fairly important, the engine is just half the size. In the end, this means for commercial engines you need a lot of more weight in order to get the same kind of engine power as for a military engine. And in the end, this could lead to commercial ships barely registering any speed advantage from adding additional engines, because there is a diminishing efficiency for these engines in relation to the added weight. Okay, but as you can see, this project would cost us 1,500 research points, and I am willing to cheat a bit here with the Space Master, but not this much, so I will lower those engines down to size 10. Just 600 research points, which is actually one of the reasons why I rarely tend to build very large engines during the game. I'm just not sure if the additional research is worth it, except fairly late in the game, but at the beginning it will be very likely that we will skip through the tech tree fairly fast, and in my opinion it's not worthwhile to spend this many research points on an engine we will use for 1 or 2 years at best. In addition, smaller size engines mean we have more than one engine usually on each of our designs, which provides some redundancy in case one of our engines gets destroyed. Okay, yeah, we will simply build this engine for now. Instant, yes. And in addition, we will need a commercial engine at the smallest usable size, 25 here, and instant this as well. Okay, let's take a look at some of the other components here. Active sensors, we will need those in order to detect our enemies, and more importantly, in order to be able to lock onto enemies with our fire controls, which we construct a tad later. We need an active sensor which is able to see the enemy as well. Passive sensors are not useful for this. Okay, what do we have here? Sensor strength itself in addition to sensor sensitivity, so how good our sensors are at detecting enemy ships partially through passive means, while the sensor strength itself will provide the active ping in a way of this sensor, while the sensitivity is listening for the return of this ping. Sensor size, we get into this a bit later. Minimum resolution, what is the smallest size of object our sensors able to detect? This goes from 1 up to 25,000 tons. Let's start with a size of 1 here for the moment. As you can see, missiles are mentioned down here. Size 1 equals 50 tons. Missiles are smaller than 50 tons. Due to this kind of sensor, currently size 1, fairly small, would be able to detect 50-ton objects at 720,000 kilometers, but a small missile and anti-missile missiles, in addition to any missile to up to size 6, are lumped in this category, would only able to be detected at about 78,000 kilometers, which is fairly short. Research cost down here, it goes up with strength, I think. Yes. Sensitivity shouldn't affect it, if I recall correctly. Yes. And with size, naturally. So if we pick a size 5 sensor, which is decent for the beginning in my opinion, it would go down up to 600, so 5 times the value for level 1 size 1 sensor. Electronic hardening is nice versus microbeam weapons, as I explained the last time, but we will not face them as far as I know, so unimportant for us. And this sensor would be able to detect small objects at 3,600 kilometers, and more importantly, small missiles at 392 kilometers, which is not a great range, but it should be okay for the start. 600 research points, which we don't have anymore, as you can see here, but as I said, RSM in this sensor. Instant, yes. In addition to detecting missiles, we like to detect enemy ships as well. There are a couple of cut-off points, if we want to call them that. Fighters have usually sizes up to 500, sometimes they are smaller, so if you want a dedicated fighter sensor, it should be somewhere around 7 or 8. I prefer them usually. For fast attack crafts, which can go up to 1,000 tons, I prefer to research a 900-ton sensor, which we will actually be doing. As you can see, with our minimum resolution going up, the detection range will go up as well, and those sensors are able to detect other objects as well, smaller objects, because as you can see, 900 tons produces the same range as a 1,000-ton object, but it would be able to detect a 250-ton object as well at about 1.2 million kilometers. The cost stays the same, so resolution has no bearing on the component costs here. So we'll take one of those, and in order to not cheat too much, I just pick one longer range sensor at about 12,000 tons, which will increase our range up to 55 million kilometers, which is still not great, but at our current tech level, it's okay. Instant this as well. As you can see, our remaining research points vanished because we have none left. In addition to such sensors, you can construct missile fire controls down here. And as you can see, a missile fire control gets about 3 times the range. I think it's actually exactly 3 times the range for the same size sensor and for other identical parameters to what we did for the active sensor. But this kind of range, it's ridiculous since you saw our active sensors just able to track objects at about 55 million kilometers range, so we would be able to use a much smaller sensor here, actually about a third of the size. But currently I want to create wrong tab, small missile, an anti-missile fire control. If you recall, our anti-missile sensor had a range of about 380,000, so this size would be overkill. We can lower it down to, what would the one yield us? 235,000. Tad too low. 1.6. 1.6 should actually fit fairly well with our sensors, which makes sense because it's a third of our size 5 active sensor. So we take this as well because we'll want anti-missile missiles. In addition, we need some fire controls for active missiles for our missile bombers we'll build later. I'm not sure about the resolution I'll be using here. Let's see how much range. That's fairly short. 18 million. Not great, but 18 million would be more than enough to outrange all kind of beam weapons. But 80 million is a distance where some higher tech anti-missile missiles might actually impact or intercept our missiles at, and more importantly, shoot at our missile bombers. So I would really like a tad longer range, but then again, our missile bombers, which will be fast attack crafts, are limited to 1000 tons, and using more than 100 tons of those 1000 for missile fire control doesn't feel really good as well. So for now we'll stick with this missile fire control. Okay, next one, beam fire controls. Very important since I want to build a largely beam-based navy here. Those first two are from our direct research. Then we are able to modify the distance and the speed those beam fire controls are able to shoot at or track. The modifiers range from 25% up to 4 times the normal range, but the cost is, the size is multiplied by 4 as well. We will need at least 2 types of beam fire controls. The first for our Gauss turrets and the second for our beam fighters. For the moment I just focus on the Gauss turret fire control because we'll have to see what the actual range of our lasers is before constructing fire control for them. For our turrets we need a range of at least, and I'm not sure here at the moment, I have to admit, I think it's 10,000, but we'll simply stick with those 16,000 here to be on the safe side. In addition, It would enable us to use our Gauss cannons offensively if we park our fleet on a jump point and protect it, and an enemy fleet jumps through. We would be able to fire with our Gauss cannons, which don't cause much damage, just 1 point per shot. But with enough turrets and enough ships which use those Gauss turrets, they hurt, and I've fairly often destroyed enemy fleets simply via my Gauss cannons. So normal range is okay. Speed. For our turrets we need maximum speed, which would just mean 8000, which is ridiculously low. I think our fighters might not be much slower when we build them than those 8000, and decent missiles from some of our nastier alien friends, mostly precursors and invaders, are able to travel at 36,000 if I recall correctly, so our turrets will have a fairly hard time shooting at them, but this is the best we can do at the moment at this tech. Hardening can be ignored again. Platform type, we can switch between ship-based systems and PDC-based systems here, and as you can see, the range is a tad higher for PDC-based systems, essentially 50% higher. But there's a problem with PDCs, which are ground-based, and beam weapons, which is, except for meson weapons, all other beam weapons are fairly inefficient or even completely useless while used in atmospheres. So personally, since I don't really like mesons, I have never constructed a PDC-based beam weapon. There's another ship type limitation here. It means no restrictions. Can be put on anything, or fighters only. And as you can see down here, instead of the 8000 tracking speed we got earlier, fighters only provides a 4 times multiplier to this, which would be quite nice. But at the moment we stick to the basics, and I'm not sure when we will start to build actual fighters, because I prefer fast attack craft, since fighters can't be refitted. Essentially, you build a fighter, and once it outgrows its usefulness, you can use them as garrison forces, or you have to scrap them. Tad inefficient for my tastes, because, which is another feature we'll get into later, in order to fight efficiently, you should train your fleets, otherwise you get delays before the fleet is reacting, and this training can take a couple of years actually, and training fighter for a couple of years to scrap it 1 or 2 years after this because you have gotten better tech is too inefficient for me personally, so we might use this later in the game, but not now. Yeah, so this is the best we can do currently for our Gauss turrets, and we will get back to the screen later after we know what range our laser weapons have. So, yes. The next one, Seavis. I think I mentioned it earlier, I don't like Seavis. It's nice as a last line of defense, but I prefer my Gauss turrets to deal with enemy missiles for the complete fleet instead of Seavis just protecting the ship it is installed on. Cloaking devices, later game feature in order to hide our ships effectively, but this I can tell at this point, you will never really be able to hide a ship, because as you have seen, we can construct active sensors which are able to detect a size 1 missile. You will never get a ship below size 1, so you will always be detected. No invisibility, sorry. EM detection sensors, passive sensors can be nice, because as long as you stay at size 1, this is valid for all sensors, your ship will still count as commercial. And having commercial ships is nice, since they don't suffer breakdowns, they don't need maintenance. But at the moment, it's one of the cheaper techs, as you can see, but at the moment I'll not be bothered with it, especially since we're essentially cheating here anyway. Engines we already got. Gauss cannon. This is another important one. The Gauss cannon has 3 features, parameters: the rate of fire of the cannon, research bias, the launch velocity, which determines the range of our shots. 2 means 20,000, 1 means 10,000. We'll stick with 20,000 for now, because as you can see, it will not change our research points, which is the most important features. It does not even change the material costs. The final tab is a tad more interesting, because as you can see, we are able to trade size for accuracy. A standard Gauss cannon has a size of 6 and fires at 100% accuracy. We can lower this down to 0.75 for heavily reduced accuracy, and the larger our Gauss cannon gets, the better the accuracy will be. And as you have seen before, we are only able to track at a speed of 8K, which is not good, so we will need all the accuracy we can get, otherwise we'll hit nothing. So, okay, let's construct this one. Next point, microwaves, unimportant, jump engines. Those are the 3 techs we have researched. Size determines how large the ships are which can travel with a jump ship. It goes from 15 to 1000, but 1000 means it has a size of 1000, so not really feasible at this phase of the game, but this will get better with higher jump drive efficiency. For the moment, I'll postpone building a jump drive, because we'll have to see how large our jump ship will be. Most likely we'll settle for something in the 4,000 ton range. And finally, you can choose between a military jump drive and a commercial jump drive. A commercial jump drive has 10 times the size and a tad less than, 8 times the movable tonnage. The main problem, except the size, with a commercial jump drive is that you are not able to do a military jump with this. And a non-military jump will always end up right at the jump point, so our offset technology up here will be completely useless with a commercial jump drive. But as I said, I postpone this for now. Lasers. Okay, here we are. We can research laser size and wavelengths, in addition to the capacitor to recharge rate. Actually, we can research all 5 of these points here. We are able to trade size for recharge rate, but since we haven't researched the tech yet, we can do nothing here. What we can do is use not just standard mounts, but spinal mounts. What's the difference between a standard mount and a spinal mount? You can only use 1 spinal mounted laser per ship. So this is very nice for fighters or fast attack craft, which are essentially 1 big laser with a few engines tacked on and fire controls and armor. But useless for capital ships. Capital ships always will use standard mounts. The laser size determines the damage and the range. If we go to our low size, you see we have just a damage of 3 and a range of 90k kilometers. If we go up to 15, it doubles to 6 and 180. If we add a spinal mount, or if we use this laser on a spinal mount, we'll get another damage and range boost, but it will cost us more power as well. Essentially, and I think this holds true throughout the game, for each damage output point we need 1 point of power. And since our capacitor recharge rate is limiting us to 2 at the moment, we'll only able to put 2 charge points into our laser, so it will take us 25 seconds before we would be able to fire this laser again. Due to this, it's usually a trade-off between high rate of fire with lower damage or low rate of fire with high damage. But with fast attack craft, it's often fairly viable to go for a higher recharge rate. Essentially, you're moving into range, fire at the enemy, move out of range again, stay out of range, recharge your laser, go back in again, and shoot at the enemy. It's one of the basic beam tactics versus harder enemies, because usually, and as the tech gets better, this is even more viable. You are able to defeat an enemy ship with a salvo of lasers from a couple of fast attack crafts even before they're able to react. If they're leaving a jump point, or if they've just come through a jump point, and even in open space, you are fairly often able to inflict serious damage. But the important thing is after you've dealt with enemy missiles. This will be one of our biggest tasks and biggest challenges while using beam fleets, getting rid of enemy missiles or protecting against them. Okay, but what will we do here? Size 6 means 300 tons out of 1000 tons for fast attack craft. I'll design this laser for now. Okay, but will I pick a backup? I'll have to make up my mind about this one a tad later, maybe while we're constructing our ships. As you can see, the maximum range of our laser is 270k, so we know what kind of range we could aim for with our fire controls. But even if our fire controls are shorter ranged, which will be the case here, going for longer range is viable, because the laser's damage gets lower with the range. Dissipates? Not important. It gets lower the longer the laser had to travel through space. So it's nice to have longer range, because at short range we will cause higher damage, and if our beam fire control would just be able to fire at a range of 60,000 kilometers, we would most likely get a damage of 6 to 7 at this range, but we'll see this later as well. Okay, magazines. Magazines are important for our missiles. This 80% up here means how much of the magazine size is used for the feed mechanism. In this case it's 20%, and the higher attack gets, the lower the feed mechanism percentage is getting. Magazine injection system is important. If our magazines get hit, it's very likely that they will explode, and if a magazine which stores 100 missiles explodes, it's not pretty. Due to this, we are able to armor our magazines, and this hits to kill is essentially kind of life points for the magazines before they will explode. But at the moment we are hopeful that we will not get hit. That's the aim of the game here. So we'll stick with hit to kill 1. Magazine size. As you can see, at size 1 we would be able to store 16 missile points. Size 1 missile equals 1 missile point. So a size 10 magazine, and I don't want to go overboard here as well, would mean we are able to store 160 missiles. So yes, we will take this as well. Mason cannons, we don't have the tech. Missile engines, we'll get into this later when we start to construct missiles. Missile launcher. You can pick launchers from size 1 up to size 100. Size 100 would mean 100 tons. If you recall the sensor size discussion, this would mean an object size of 2, fairly large. I personally have never used an engine larger than 10, which are kind of torpedoes or special buoy deployers or anything like it. For actual combat missiles I stay usually at the size of 1 for anti-missile missiles, and often, but we'll have to see about this later as well, size 6 for my offensive missiles. But stick with the 1 for now. Reload rate, we don't have any tech here. Due to this, it will take our launchers 30 seconds, even for fairly small missiles, before they're able to fire again. This is abysmal, but the best we can do at the moment. There are different platform types here again, ship-based or PDC-based, and as you can see down here, if we pick a PDC-based system, the rate of fire is doubled. And since we will be building a couple of PDCs, or at least one PDC right at the start and more later, which are using missiles, because it's the only thing we can use against enemy missiles, since we have no mesons, we'll construct one of those in addition to a ship-based system. The launcher size down here, it's a usual trade-off. As you have seen more than once already, we can trade size for reload rate in this case. We researched up to box launcher size, which means we will able to reduce the size by a factor of 6 to 7 for our launcher, but are not able to reload our missiles outside of a missile outside of a ship hangar. So it's just useful for carrier-based fighter bombers or ground hangar-based fighter bombers. For ships, it would be possible to lower the launcher size in order to get more missiles in the air, which is a good idea for offensive missiles, but usually not a great idea for defensive missiles. We want our reload rate as high as we can get, and it's still 30, still abysmal. I'm not sure if I've actually constructed this. Let's take a look at ship construction, new, just a dummy name. We'll get into this later as well. I just want to see, yes, we constructed a size 1 missile launcher. Okay, back to the tech design. New species, it's for genetically altering our species to have better tolerances for some planets we might find later, but we'll stick with terraforming those planets. We don't have a particle beam cannon, we don't have plasma cannons. We will need a power plant for our laser. Let's take another look at the laser, what kind of power plant we will be needing. I think it's 2 power points. Exactly. It's able to recharge 2 power points per second, so we will want a power plant which generates 2 power points. On the other hand, since our power requirement is 9, and we will need 25 seconds to recharge anyway, we could get away with a power plant which produces 1.8 power per 5 seconds. Let's look at those plans. Gas cooled. This is technology based. I personally don't like reactor power boost, since if those reactors get hit, they have a higher chance to explode. Not good as well. Not as bad an explosion as with a filled missile magazine, but still nothing we want to have. So as I said, we want power of 1.8, and since the power output for a 0.1 reactor size is 0.45, we will exactly get 1.8. Okay, let's rename this a bit. This is one of the more stupid names in my opinion. And those, no, 0.4 for 1.8 instant. Yes. What else have we got here? Railguns, we don't have this tech. We don't have shields, and thermal sensors are essentially the same as the EM sensors, only while EM sensors will detect enemy energy signatures, thermal sensors will detect enemy thermal emissions, mainly engines and populations. Okay, I think we've got our basic techs, except for beam fire control for the fast attack craft. Before we will construct it, we will have to see how fast our fast attack craft is actually going to be. But one thing we know, if we want long range, and for beam weapons, range and speed, ship speed in this case, are the key stats. So we would love to have a range of at least 64k, but this would mean size 2. If we manage to get the speed of our fast attack craft up to 8000, this would be a size 8 sensor, essentially meaning 400 tons, so 40% of our fast attack craft would have to be dedicated to a beam range fire control, which is overkill. We will not be able to do this. We will either have to stick to a lower range, or maybe even a lower tracking speed. Essentially, we have to see how much space we have left after installing the main components and see what we can actually still fit in there. Okay, let's construct our first ship. We have a Blücher cruiser. Since this will be our anti-missile design, I prefer to turn it into an escort destroyer. Design view, it shows some basic components, some of the stuff we've researched, and some things which will mainly be used for commercial ships, which we will construct later as well. For now, we have to spend some thoughts about what should this ship actually do. And what we want to do is we want to use Gauss cannons to protect our carrier, to protect our fleet. We want some anti-missile tubes in order to engage enemy missiles at longer ranges and thin out their volleys. Because the number of volleys is fairly important in addition to the number of missiles in this volley. each of our fire controls, and I think I can show this better by actually putting one of our Gauss turrets, which we haven't researched yet. Okay, another thing to do. Turret design. There are different kinds of turrets with from a single gun cannon up to a quad setup. And if you take a look at the size down here, we are using a 6-ton size 6 cannon. The turret adds a size of 3 to this. If we go to twin, we don't get 18 but 17.7. Triple, again more efficient. Quad, again more efficient. But an overall size of 35 is fairly hefty. There are a couple of additional parameters here. As you can see, we have a tracking, or this setup would have a tracking speed of 10,000. If you recall, our beamfire control only has a tracking speed of 8,000, so it would be inefficient to leave it up here unless we would expect to get a better beamfire control fairly shortly. So you are free to use higher tracking speeds, but personally I tend to stick to the tech I'm needing right at the moment, and as you can see, the size got a little bit down. Okay, nothing else we can do here. We will not armor our turrets because we are still hoping to pick up all enemy missiles from range, even if this is unlikely at our current tech level, but I don't care about this at the moment. This is one of the techs I can't instantly research. I've actually get down to the research and look for our turret under energy weapons, if I recall correctly. Yes, and here we will be able to instant it. Normally I would have had to research this tech even under my house rules, which gives me free components for tech for up to 280 tech points. So instances for now as well. Close, back to the ship design. Where it is, here it is. Gauss cannon. Yeah, I want to show another thing here. If we put a Gauss cannon into this design without any turret, our tracking speed would be 2000. Why is this the case? Normally the tracking speed is the lower of the ship speed and the give me a word. I'm wrong. Not the lower, it's determined by the ship speed, but there's an exception. It will always at least be equal to our current beam speed technology. Where it is? Sensors. Exactly. Our fire control speed is at the moment at 2K. The next step would be 3K. So due to this, even since our ship has no engine at the moment, the tracking speed would normally be 1. It is 2K at the moment. This is a main use of turrets. If you cannot get the ship speed up to potential turret tracking speed, turrets are always a very attractive alternative. So let's try to put in 2 of those turrets. As you can see, we have 1 turret at the moment, which is able to fire 8 times. Each of our cannon can fire twice due to the range of fire, and we have a quad design here, so each turret fires 8 times. So essentially, if we would engage a flight of missiles, we would fire 8 projectiles at it. If the flight has more than 8 missiles, we would not be able to do anything about them with this Gauss cannon. but other Gauss cannons in the fleet or on the same ship can shoot at the same flight of missiles. It would get a little bit more dicey if we face two flights of missiles. Let's say our current ship faces two flights of missiles with 4 missiles each. For each turret and each fire control, we are only able to fire at one flight of missiles. So if we would want to shoot at more than one flight of missiles, we need at least another turret and another fire control. So more than one fire control might be viable for anti-missile ships, but since our rate of fire is fairly low, I think we can get away with 2 turrets and just one fire control here. Where is our fire control? Beam. Fire control, there it is. And as you see, we go up to 8k tracking speed, despite our ship still just being, or just having a speed of 1k, since it does not have any engines. What else do we need for a missile defense ship? We need an active search sensor. And in order to engage anti-missile missiles, we need a size 1 sensor. As you can see here again, range of 3.6 versus 50-ton objects, range of 390 versus size 1 to size 6 missiles. This fits in with our Gauss cannon and the fire control. We'll see them a bit before our Gauss would be able to engage, but this is one of the reasons why we want to have some anti-missile launchers on this ship. The one we constructed earlier, size 1 launcher. In addition, we'll need our missile fire control. Again, important here, in order to shoot at size 1 missiles, we need a resolution 1 fire control. And as you can see here, the fire control has a range of 3.5. Our active sensor has a range of 3.6. So a fairly good fit. Unless, which is the problem again here, we will only able to detect small missiles at a very short range, but having this additional range is still useful because we will be able to use those missile launchers against enemy fighters as well. And an enemy fighter will have a mass of at least 50 tons, so our sensor will be able to detect those at 3.6 kilometers, and our missile fire control will be able to engage those at 3.5 kilometers. So everything fine here. As you can see up here, our ship is already fairly heavy. I want to build this ship at a size of about 8,000 tons. And when you design a ship, you should spend some time thinking about how many engines do I want to use per ship tonnage. Personally, I like to stick to one size 10 engine with normal modifiers. For each 2,000 to 3,000 tons of weight. So let's see how fast our ship would be with 4 engines. Close to 4,000, which is a decent speed for iron speed tech, but currently we just have 1 missile launcher, so we'll need some additional components. We don't have a magazine for our missiles at the moment. We need one of those. We're up to close to 7,000 tons. We don't have any fuel. We don't have any maintenance capacity or just basic engineering here, which means our ship would break down most likely during the first 2 months of its voyage. we will need a longer deployment time for our ship, because 3 months is a tad short and the crew gets unhappy if it has to stay in space for more than the intended deployment time. I like to have 2 years deployment time here, and we will start to add some engineering. As you can see, the maintenance life goes up, the MSP goes up. It's a kind of mixture of maintenance points and repair points, or repair prevention points, however you want to call it. And down here is another important step, is that max repairs. This means how much repair points are needed to repair our most expensive component if it breaks down. You should always have more MSP than max repair. This step means the annual chance that let's see it again. Annual failure rate, exactly. Best take a look at those abbreviations. It's quite useful, but for me personally, I just tend to stick with maintenance life and making sure that MSP is larger than max repair. So we will need quite a bit more of engineering. Most likely we'll need another one. So at the moment we would be at 2.7 years for 2 years deployment time. Looks good. We have still some space to spare, but we will still need more missiles than the one we got here at the moment. And we have still no fuel. We'll need some fuel first. 5 missile launchers. That's fairly pathetic. 8,000 tons are reached, and always try to remember to look at the exact class size, because it will show 8,000 tons even before you really used up all the potential ship size here. So let's take a look at the ship. Is this viable? We don't have any armor, which is not good, but hopefully should not really kill us, since the main idea is that these ships stay out of range of the enemy. We have our fast attack craft to get in the enemy's face, not our destroyer escorts. What else have we got? Our maintenance life is fine. Later when we research other techs, we are able to build smaller engineering spaces, because at the moment we are wasting some size points here. MSP about 3 times our max repairs, this is okay. And we failure rate 100%, that's okay. 24 month, our magazine is actually oversized, and I think I will build a smaller magazine, because at the moment we would be able to store 166 size 1 missiles for 6 launches, which is too much ammunition. I prefer about 10 reloads, sounds good. So if we save some weight from using a smaller magazine, size 10 here, what would a size 6 offer us? Size 6 should give us around 100 points and would give us 4 additional launches. Yeah, sounds good. 100 magazine for 10 launches. Let's build a somewhat optimized magazine. This is one of the other points when I'm fairly willing to use Space Master, because I can assume my engineers would be able to tell me what a ship would look, how a ship would look like, and make some suggestions for optimal magazine size, number of missile mix. So I have no qualms here in using Space Master to change some components I've actually already researched in the game, because I would know what the optimal components would be, and thinking hard about how to build the optimal component is a tad too much micro for me. Magazine size 6. Misclicked. Yeah, 69. Looks good. Instant yes. Close. Get rid of this magazine and put the other one in. And put 4 additional missile launches in. There it is. Oh. Okay, now we're tick over size. We have to lower our missile launchers, and we need some additional fuel because 11 billion kilometers is still a fairly pathetic range, even for a ship which will mostly be there to protect our interest in Seoul, and maybe make some jumps later on with the help of a tanker which will keep it fueled up, but still some additional size would be nice. Here's the thing I talked about earlier. It shows 8,000 tons, but in reality we have about 0.8 tons left, so we can add some small fuel storage. Now we are at 8,000 tons. 30 billion range, the rest hasn't really changed. The magazines are still a tad on the large side even. Our speed is fine. Fuel not great. We have 2 Gauss turrets. We have fire control for our Gauss turrets. We have a couple of anti-missile launchers. We have a missile fire control, and we have an active sensor. There are no design errors. Always remember to look into this field. The program will show you some of the more obvious blunders and tell you about them here. Okay, we just constructed our first ship, and I think this is a very good time to end this episode. Thank you for watching. Bye bye.